Welcome to Next Gen Manufacturing Nexus. Today, we're diving into a hidden war, one that's being fought all around us. It's a battle against a silent enemy that threatens our bridges, our pipelines, our entire industrial world. And this is the story of the engineers on the front lines.
So to really get a grip on this fight, you first have to understand the sheer scale of the enemy. We're talking about a natural process, an elemental force, that costs us, well, more than you can probably imagine.
Just look at the difference here. On one side, you've got a brand new, pristine industrial pipe, and on the other, you see the destructive power of corrosion. It's the gradual decay of materials, a slow-motion attack by their own environment that eats away at our infrastructure until strong steel becomes a fragile, dangerous liability.
And the price tag? It's absolutely staggering. Every single decade, just in the United States, corrosion silently drains between $2 and $4 trillion from the economy. Let that sink in. At the high end, that's more than the entire annual economy of a country like the United Kingdom. This isn't just about a little rust on a fence. This is about massive economic loss and, honestly, compromised public safety.
You know, one expert described corrosion as a plague, and that analogy is just perfect, isn't it? It's the perfect description for something that works quietly, totally unseen, until a catastrophic failure, like a pipeline rupture or a bridge collapse, makes all that hidden damage tragically visible.
So who fights this plague? Well, that brings us to a fascinating and honestly a pretty little-known field of engineering. Let's meet the specialists who are our primary line of defense, the corrosion engineer.
At its heart, corrosion engineering is all about applying science to slow down this inevitable process. Because here's the thing you have to understand. You can't stop corrosion completely. It's a fundamental law of nature. But with the right expertise, you can manage it, mitigate it, and control it to keep our critical assets running safely for decades.
And this isn't some lonely, siloed field. Not at all. It's really a nexus of a whole bunch of different disciplines. Corrosion engineers are pulling from mechanical, chemical, material science, and even civil and marine engineering to attack the problem from every possible angle.
Okay, I know what some of you might be thinking. You hear corrosion and think it must be a super niche, maybe even boring career. But the reality is the complete opposite. It's a huge, in-demand field, and it's a critical piece of a much bigger puzzle called asset integrity, which is all about making sure our industrial world keeps running safely and reliably.
So what does a corrosion engineer actually do all day? Well, their day-to-day work is way less about routine tasks and much more about solving incredibly complex mysteries. It really is a day of detective work. As one industry pro puts it, it's like forensic pathology but for materials. You're hunting for microscopic clues, analyzing evidence from the environment, and piecing together a story to figure out not just that a material failed, but the precise reason why it failed. And their investigator process is incredibly dynamic. It kicks off with hands-on field inspections, sometimes in really challenging spots, like an offshore oil rig. Then it's back to the lab for failure analysis. Based on that evidence, they design new strategies, and, this is key, they work with a huge range of teams, from technicians all the way up to executives, to put those plans into action.
Okay, so to win this fight, our industrial detectives need a pretty sophisticated set of tools. And their toolkit isn't just sitting still, it's constantly evolving to take on new challenges.
So the core of their arsenal has four main strategies. You've got protective coatings, which act like a shield. Then there's material selection, making sure you use the right metal for the job. Cathodic protection is actually genius. It's like giving corrosion a decoy, a sacrificial metal that corrodes instead of the important asset. And finally, you have chemical inhibitors that can make a hostile environment a little less aggressive.
But that's the classic playbook. The next frontier is here, and it's digital. We're talking about digital twins, a complete, real-time virtual replica of a physical asset. And this is not just some 3D model. It's a living, breathing simulation that's constantly being fed by real-world data.
And the difference this makes? It's like night and day. See, traditional methods rely on periodic, on-site inspections, which means you're always reacting to problems. A digital twin, on the other hand, gives you remote, continuous monitoring. It pulls all the data into one spot and shifts the whole game from being reactive to being proactive and truly intelligent. So here's how this magic actually works. You've got sensors on a real pipeline collecting data on things like temperature or wall thickness. That data streams directly into the virtual model. Then, AI runs predictive analytics to forecast where corrosion might happen next. This lets you do maintenance only when and where it's actually needed. It is a total game changer.
So, this new technology is completely transforming the field. And that's a good thing, because the fight against corrosion, it's only getting more critical. So, let's take a look at the future of this battle.
There are two massive challenges coming up on the horizon. First, our global infrastructure, from bridges to power plants, is aging, and we're going to need more experts to manage it safely. Second, the big shift to a hydrogen economy, that brings a whole new set of problems, since hydrogen can make certain metals brittle. That means new materials and totally new strategies.
And here's why all of this matters to you. The work of these industrial detectives is directly linked to public safety, to our economic stability, and to our ability to successfully transition to cleaner energy. Plain and simple, without them, our modern world just couldn't function.
So that leaves us with one final thought. As the stakes get higher and the technology gets smarter, the need for these experts is only growing. The real question is, who's going to step up and become the next generation of industrial detectives?